The Riemann hypothesis is one of the most famous, unsolved problems in mathematics. It's named after Bernhard Riemann, a German mathematician who proposed the hypothesis in 1859. The problem is so important that it's one of the 7 Millennium Prize problems, for which the Clay Mathematics Institute offers a $1 million prize for a correct solution. To understand the Riemann hypothesis, we first need to understand a bit about complex numbers and functions. A complex number is a number of the form a by, where a and b are real numbers and I is the square root of -1. Complex numbers can be added, subtracted, multiplied, and divided just like real numbers. A function is a rule that assigns to each input number an output number. The Riemann hypothesis is about a particular function called the Riemann zeta function, which is defined for complex numbers. The Riemann zeta function is a bit complicated, but it's closely related to the distribution of prime numbers, which are the numbers that have exactly 2 distinct positive divisors, 1 and the number itself. The Riemann hypothesis is a statement about the zeros of the Riemann zeta function. A zero of a function is an input for which the function outputs 0. The Riemann hypothesis says that all non-trivial zeros of the Riemann zeta function have a certain property, their real part. The a in a by is 12. This might seem like a technical statement, but it has big implications. If the Riemann hypothesis is true, it would give us deep information about the distribution of prime numbers. In particular, it would tell us that primes are distributed as regularly as possible, given their overall density among the integers. Despite over a century of effort, the Riemann hypothesis remains unproven and is one of the biggest open problems in mathematics. Many of the most important results in number theory in the past century have been conditional results, which are proved under the assumption that the Riemann hypothesis is true. Proving the Riemann hypothesis would not only confirm these results unconditionally, but would also likely lead to many new insights in number theory and related fields.